Hey guys, I am Jim Pytel from Columbia Gorge Community College's Renewable Energy Technology program. This is EET 121, Digital 1, and last lecture we discussed fixed function devices, and when I was talking about fixed function devices, fixed function integrated circuits, I mentioned that was just one category. Well, here's the second category, programmable logic. I said more on that later. It's now. Okay, so let's go ahead and discuss these guys. Okay, so a programmable logic device is basically in contrast to our fixed function devices there. It's a logic function, it's programmable by the user. You can use them a couple times too. If you don't like that program, you can just erase it and put a new one on there. They don't look anything different than anything else out there. You know, it looks like a black plastic chip. And it's got these little connectors on it. Sometimes they fit in special housing, sometimes they're mounted to it, so you just got to know what you're dealing with. So again, programmable logic device, PLD. There's one thing about this course, lots of acronyms. Program, 2 M's, logic. Okay, and then okay, so basically what are the advantages of these guys here? First one, basically, smaller size. You see that star? What the heck is that? I have honestly no idea what that is. I hope you guys are seeing that. This guy right there. What the heck is that? Now it's moving away. All right, smaller size. Yeah, more devices in the same area. 2, basically it's readily changed, basically by rewriting your program. You don't have to rewire or replace components, you just got to reprogram it. 3, it's implemented faster. A design can be implemented faster. This is to say this, provided speak the language. That's the key point there, is you got to know how to program these things, and they are substantially faster than a fixed function. We'll go into some of the other advantages here. So just like our fixed function ICs, where we have, let's go back to our IC packaging here. Here it is. Remember how we have different levels, going from smallest to biggest? You know, where we got SSI, MSI, LSI, VLSI, ULSI. So small, medium, large, very large, ultra large. We've got the same thing for programmable devices, except they have different terminologies. So SPLD, CPLD, FPGA. Same thing. Smallest, largest, most powerful. So, SPLD, S stands for simple, programmable logic device. C stands for complex. FPGA doesn't stand for anything in our pattern before. It's field programmable. Gate array. And I don't understand it. These are also field programmable, SPLD, CPLD. Those are also field programmable. I don't know why this one is so special. Field programmable. I don't know why they choose to designate it that way. But to go back here again, SPLD, it takes up a couple. It says several SSI or MSI chips. That depends. Again, what's our levels for SSI 0 to 12? Again, you don't need to worry about the numbers. Now CPLD 2, 4. Let's see, not even say 4. 2 264. see how these are smaller units? You know, and a CPLD is made up of this. FPGA, there's no real definition, but again, it's just huge. There's I think what we find coarse and fine. We'll get into these things. But just notice that smallest to largest. Okay, we want to talk about is how you program these things. Basically, there's two ways to do it: visual and text. Just like they described. Visual, sometimes it's drag and drop on a computer. Now, I mean, think about this: like you've got a computer that's got like a little cable coming out, and it's plugging into the PLD, and you're on the computer screen just dragging and dropping, making schematics, making a counter here into a register. You're almost making like these are virtual components right here. That's virtual, but it's just on the screen on that computer. It's dragging and dropping, making these little connection points in between. So here's your wire. It's from here to that one. It's going to, I don't know, over this thing, which is some other virtual device. I don't know what it is. But anyways, all you do is drag and drop it, and then the computer sends that to the PLD, and it beeps and whirs, and it comes out with basically the fixed function equivalent inside that PLD. Okay. Text, just as the name implies, written instructions. Very similar to a C program or something like that. Well, not C, just hardware definition language. Depends on who makes the PLD. Some of them have different languages. Okay, so written instructions, drag and drop. One thing I did want to say, this is using components. I have seen something very akin to a decision, like a flow chart. Visual means a program. How to program. So visual, you can drag and drop components, or something akin to a decision flow chart. You got text, written instructions, and the written in the hardware